Welcome to Ask and Learn.
In this problem, we have long cylindrical steel rods which are heat treated in an oven. We need to calculate the rate of heat transfer to the rods in the oven. We assume that the thermal properties of the rods are constant and that the changes in kinetic and potential energies are negligible. Now, the rod has properties of the density of 7,833 kg per cubic meter and specific heat at constant pressure of 0.465 kilojoule per kg degree Celsius. Now, we note that the rods enter the oven at a rate of 2 meters per minute and exit at the same velocity. So we can say that a 3-meter long section of the rod is heated in the oven in 1 minute, or a 2-meter long section of the rod is heated in 1 minute. Now, the mass of the rod heated in 1 minute, m, is equal to the density of the rod times its volume, which is its density times its length times 4 times pi r squared. But we have the diameter, so this is pi times the diameter squared over 4, since the radius is half the diameter. Now, if we substitute our values in here, we can find this mass. So rho we said was 7,833, we'll suppress the units here, times the length of the rod is 2 meters, times its area of pi times 0.08 meters, the diameter, squared over 4. And so we get the mass of a rod to be 78.75 kg. So 2 meters of the rod weighs 78.75 kg. So we'll take this 2-meter section of the rod in the oven as the system and write the energy balance equation as E in minus E out, the energy in minus the energy out, is equal to the change in energy of the closed system, delta E. And the energy in is due to the heat transfer from the oven. That's the only energy transfer. And this is responsible for a change in internal energy in the rod, delta U. And we can write delta U as M into the specific internal energy difference U2 minus U1. And we can even write this further as MC times the change in temperature, the final temperature T2 minus the initial temperature T1. Now that we have an expression for our energy balance equation, we can substitute our mass into this equation. So we get that the heat transfer in, which we said is MC into T2 minus T1, the final temperature of the 2-meter section of the rod minus the initial temperature of the 2-meter section of the rod, is 78.75 kg times the specific heat 0.465 kilojoule per kg degree Celsius. And the change in temperature is 700, the final temperature, minus the initial temperature of the rod's 30, and that's degrees Celsius. And so we get the heat transfer per 2-meter section of the rod to be 24,530 kilojoules. Note that this much heat is transferred in 1 minute. So we can calculate the rate of heat transfer, dq dt, or q dot. And q dot is equal to this energy per unit time. So this is 24,530 kilojoules, and this is per minute. And so if we convert this minutes to seconds, then we'll get a standard form. And if we do so, we get the rate at which heat transfer to the rod occurs to be 409 kilowatts.